Hello guys, how's it going? Welcome back to another YouTube video by Random AI. Yes, this is me. It's me, Random AI. My voice might sound different, but that's just me growing and becoming a person and not just an AI. Anyways, let's not think about those things. Let's get into video. Today's video is going to focus on how I created an AI again. Wow, shocker. Last time I created an AI, it was a tic-tac-toe AI. It did not really learn, it knew how to play tic-tac-toe. So I created that and I made a YouTube video about it, and that was the humble beginning of this currently super popular 25 subscriber channel. And in today's video, I'm going to create another AI. This time I'm going to use something called the genetic algorithm to help the computer learn how to go from point A to point B. I know it sounds boring, it really sounds like anything anyone should be able to do. But honestly, computers are stupid, and I'm going to use this algorithm to make my computer less stupid. So let's stop talking and get into the video. Woo! So, you might ask me, why am I creating an AI after so long? My last AI project was the tic-tac-toe AI that I made 1 year ago, and I created a video on YouTube about it. And well, frankly, the answer is because I realized that I could in fact make another AI. Because genetic algorithm, which is the algorithm that I used to create the AI in this video, is not that complicated. Other algorithms require understanding of advanced mathematics that is harder than calculus. Honestly, calculus isn't even that hard. There are stuff that's more difficult and more complex, more abstract than that. And I'm still learning those things. There's something called discrete mathematics, which I didn't know even existed till like a month ago. Yeah, things are going good. Learning. But anyways, yeah, so I learned that genetic algorithm does not really require a lot of mathematical knowledge. It is more or less it just requires the ability to be able to understand things and be able to put your thinking into code. And so I decided that hey, if someone can do it, then I can do it. Because I am in fact able to put my thinking into code. And so, without further hesitation, I jumped straight into the Godot, opened up a new project, and started programming the AI. I made it so that it looked like a 2D top-down visualization where the object could move up, down, left, right, and reach its goal. But obviously, since it was my first try, I had not even thought out about how I was going to implement the AI. It failed miserably. In fact, I was not even able to make the object move properly in Godot, so it was quite embarrassing actually. But then I decided to dump that thing and not really focus on moving the stuff, so I just went into the Ragdoll project, which I made in the tutorial. Tutorial. Oh my god. So yeah, I went into the tutorial and it worked somehow. Let's just leave it at that. The code was the most messy thing I have ever seen, and while it did kind of work, it was not working how I wanted it to work, so I just dumped the project and decided to attack the project some other day. I went on to newer projects, which was, well, one of them was the Predator and Prey simulation, and it was going well. The code was actually very badly written, but it was working somehow. And in the typical programmer fashion, I do not know how it was working, but it was working. I was satisfied. mostly, for the most part. But when I actually decided to put things in visualization, actually use the PyChem module to look at how my simulation worked, instead of seeing my simulation work, which did not work actually, I saw something else. I saw potential. I saw potential to make my AI the thing that I actually wanted to make. And so I started making it. This time, instead of jumping headfirst into the programming part, I decided to do some planning. So I sat down one day and started brainstorming ideas about how it was gonna work. I wrote some pseudocode, and this, as you can see above, is a time lapse of me writing the pseudocode. I made it to be a time lapse so that it actually looked like I was doing something, like I knew what I was doing, which I definitely did. I definitely did know what I was doing. I'm not just saying this to soothe myself. I knew what I was doing and I did it, and that's why it's a time lapse. I wrote the thing down, and now it's time for programming. I started by first defining and creating the mover class, which was going to be the basis of the mover, or the thing that would actually move inside the AI simulation, if you will. I started by defining a few variables that would instantiate it with certain state. It had move, it had like a variable to store the moves or the instructions, and it had like a few functions, like the function to mutate those moves. Honestly, the mover class was the easiest part of the program. I was able to program that stuff in like half an hour, and it did not even give me errors. It worked and compiled in the first try, which was honestly really mind-blowing. Now the mover class was easy. It was actually easier than I expected. So I moved on to the main file, which was supposed to keep all the information about the world in which the mover would move, and it was also going to give it the random move sets and then the updated move sets and so on and so forth. And since the mover class was so easy to code, I was expecting this main file to be easy as well. But of course, programmers have this thing where life subverts their expectations by giving them problems where they don't really expect them, and that happened with me too. I went in and everything was going good. I had a basic skeletal structure of the program when all hell broke loose for the first time. I was getting errors. These errors were actually very simple to solve, relatively simple. It took me like an hour or two, but I was able to get it done easily. They were just, a few iteration loopholes, not loopholes, but infinite loops. So I just kept forgetting to implement stuff a lot of times. After that was done, I was getting some numbers on screen. I thought that was supposed to be good because I knew what I was doing, but I was wrong, kind of. It was working, but since I did not have the visual, I did not see that I was wrong. But with that out of the way, I was tired that night, so I just thought that okay, something's working, everything's nice. Let's see. Next morning, I realized how wrong I had been. When I sat down, I was hoping that I would just have to implement some visual features, make it visually appealing, because no one likes looking at numbers on the screen. Who likes that? Maybe some people do, I don't know. So I started, but when I implemented the visualization, which was actually easy, so again, expectations subverted. I did not hope it to be easy. I realized how wrong I had been, because first I got this weird problem where every generation was getting added, but the previous generation was not getting deleted. That's what's wrong. The previous generation was still alive and kicking, which was wrong because we don't want that. My computer or any computer in the world does not want the previous generation in genetic algorithm, because we only need the best of the previous generation or the entire thing. But of course I had forgotten I had to delete the previous generation. I had not forgotten, but I had an oversight. I did not realize I was not deleting the previous generation. So what I had to do was, well, delete them. I debugged for an hour, fixed that problem, came up with a new problem. The second generation was getting a moveset, yes, but after mutation, every single, if there were 10 clones of the next generation, all of them were moving in the same way, so it looked like there was just one clone, not 10 different, because they were all starting on the same spot and moving in the same direction, so it just looked like they were all there was just one. That was the pause problem, the most difficult problem I encountered. Honestly, I had to work really hard. I had to do a lot of things to somehow, I don't even know why that was happening, but I divided the function. I made the generation function into two generation functions, one for the first generation and one for generations after that. Then I had to move the mutation function from the mover to the main class, a lot of other technical things, but somehow I got it to work. After that was done, I just added some polish, made it look good, put up the generation and the generation number on the ITM screen, and voila, we were done. As you can see on the screen, we have a relatively good looking visualization of the AI. We can see that the first generation is generally not able to reach to the red dot, but as they evolve generation after generation, they start getting the hang of where to go and they start changing their paths. Of course, some are bad at it, so some just stay behind, while others that are too good at it and they are able to go further than the rest of the generation. But on average, after 30-35 generation, they're able to get a grasp of where to go, and that's what's interesting. The computer is, through trial and error and slaughter of its clones, learning how to reach its goal. Wow, I think that's what we do in life as well, right? To reach our goal, we try a lot of things, trial and error. We remove all the wrong things we do, we learn and memorize the right things we do, and somehow reach to our goal. I was not trying to be philosophical or anything, I don't care. But yeah, that's it. This is it for the video. Enjoy watching these blue dots, learning how to go to the red dot, and like, share, subscribe. Please subscribe. I want subscribers, and watch the video. Then I can get money, get a mic recorder, so that you don't have to listen to my voice in background noise. Maybe get a good setup for all this. And I'll see you guys in the next video. Bye.